So, hi, I'm Justin Paglierani. I'm a staff security engineer at Flatiron. What that means is I'm the team lead for the cloud security team. Prior to Flatiron, I worked at Bishop Fox as a pen tester and various quasi-governmental organizations before that. So I've been around for a little while. Yeah, I guess that's kind of me. Sahir?
Sure. So I'm a senior security engineer at Flatiron Health. I've been here for like 3 years, and then before that, I was a software engineer and did software engineering for like 3 years. And that's pretty much about me.
Yep. So for anybody who doesn't know about Flatiron, we basically use technology to try and fight cancer. We're not going to be talking about any of that today. We're going to be talking about cloud security, misconfiguration detection, and remediation. So kind of going into that, we can move to the next slide. Sorry, we were playing the slide dance. We got some special. Scott Piper from Summit Route has helped us out quite a bit with this, as well as Reza, who is our summer intern. He's a PhD student, and he did some really great work for us as well, helping us build this out and put it to good use in our environment. So kind of on from there, we'll get into the agenda. We're going to kind of give you the background of the problem we were facing, kind of our first iteration of a solution, kind of where we're at now, the things that we've solved for, a quick demo, and a Q&A. So kind of our general background here is we kind of wanted to know how our critical resources are configured. We wanted to be able to detect if things become configured badly, and if they become misconfigured, can we fix it in a reasonable amount of time automatically without having to be on call at night, because nobody wants to do that. So kind of generally why we want to do this is because cloud configuration problems are pretty easy to accidentally do in the new kind of DevOps, well, newish DevOps paradigm, where we've now decided that the software engineers or sysadmins, mistakes happen, and we end up with lots of things like S3 buckets being exposed, people losing IAM tokens through IMDS, all kinds of weird things, basically through like silly misconfigurations that if you kind of like thought through, you would catch pretty easily. Like having an S3 bucket be available publicly when it has sensitive information is like logically a very simple mistake. But because of the complexities of how we are building and utilizing cloud resources, it's something that kind of happens a lot. So at Flatiron, we handle millions and millions of patient records, raw PII from doctors. So, an S3 bucket with that information becoming publicly available would, one, be a disaster for us from a business standpoint, but also be a disaster for our patients. And when you're dealing with cancer patients, the last damn thing they need is to be dealing with identity theft or even the thoughts of it. We don't want to do that. Stress is bad for health outcomes, so we're trying to avoid that. So kind of our first iteration on going about fixing this was to use lambdas, just do serverless bits of code to check over our resources every 10 minutes or so. We had a bunch of lambdas checking for a lot of different things. It generally would do one lambda per resource or one lambda per misconfiguration that would detect an issue and then fix it automatically, just kind of like your standard polling model. And when we first started doing this, we had many fewer resources. We were a much smaller company. It worked great. Things were fantastic, and it was great. So kind of the general architecture of how this worked was we had separate lambdas for each remediation. We had CloudWatch events or we would be watching the CloudWatch events from our like primary account, which we call our security account. And then the Lambda would assume roles into each of our other accounts to kind of look at resources that way. So we kind of had like a centralized little isolated deputy that would then kind of move on to the different accounts and monitor all the resources and then fix them if things were broken. And it worked. We had great things. So, we would be getting JIRA tickets that would tell us like, oh, somebody stood up this S3 bucket and it was public accidentally, but we fixed it right away. So no harm, no foul. A fidelity of about 10 minutes, so that was not so bad. It worked. It was great. Why did we move on? Well, the general problem was we were using tons of API calls, lots and lots, and as the environment grew, it got to be worse. That got to be very costly. It was causing production issues, and everyone was kind of mad at us. It was not a great thing. So we ended up with lots of rate limiting, which was, I mean, not the worst thing in the world, but it wasn't great, and it became more and more of a problem as time went on. So we kind of wanted to avoid this. Every 10 minutes, things were starting to get screwed up. So kind of our general post-mortem was, we had these cron, like basically cron jobs running to check these things. It worked very well. But polling is just kind of crappy in general. So we wanted to move away from that and move into something better, because just the number of API calls in a cloud environment was getting costly from a number of different standpoints. And then also just the general fidelity of having a 10-minute delay in response time was not necessarily great. If we could act a little bit more, I guess a quicker response would be better. When you're dealing with as much PII as we do. So kind of enter the remediation framework v2. So Sahir, take it away.
All right, so so all these problems which we saw before, like multiple API calls and also having exponential backoffs, which were like impacting other stuffs, right? And the issue also was like we had like cron-based polling, which will depend on like how is your cron frequency. Like we had like 10 minutes, but for some reasons for some stuff we had like 20 minutes also. So it was not real time, or it was not that easy to scale. So that all brought us to like work on the v2.0 of that, like how we can like aggregate all of these independent lambdas into one unified code base. So instead of like multiple lambdas, we have one single stuff where we have like multiple modules for like, let's say S3, lambda, RDS, AMIs, or EC2s. So we try to like unify everything and try to add like event-driven model. So because we know like what events would be responsible for making things. Like for example, like when we talk about S3 buckets, you would know that put bucket ACL or put bucket policy would be one of those calls, like which will make the bucket public, right? By making either slapping an ACL or slapping a bucket policy, which basically exposes your S3 bucket. Similarly, we have the same API call for other resources, like let's say EC2 AMIs or snapshots. So we wanted to like capture on that and make a framework which can tap onto these events which are happening, and then maybe trigger our framework. So if we move ahead, we'll see the architecture, like how exactly it is set up. So it's the V2 is basically you can use like multiple accounts with it, multiple regions. So if let's say if you have like 10 accounts, you can basically configure your members in 10 accounts and also the multiple regions. So how we do here is we have CloudTrail event rules, which basically capture on the events which happen in, let's say, account A. And those event could be like, hey, like EC2 modify snapshot attribute. And what happens here is that sends the events to on an event bus to your master account where your remediator function lives. So event bus basically will send that to the master account, and then on the master account you have same pattern rules which will capture on the let's say EC2 modify snapshot attribute, and then that is captured by the event translator, which is like a lambda. So it will capture the raw event and then like massage it and send that to SQSQ. And then the SQSQ is piped to the remediator lambda basically, and the remediator lambda will basically look at the resource, try to enumerate it, like what does it look like? Does the snapshot look like it has been shared publicly? Does the snapshot look like it has been shared with a random AWS account, which probably we don't own? So based on that decision, like remediator lambda will make the decision to remediate it or not remediate it. So there are like event translator and event forwarder here and remediator function, which makes it event driven. So moving on, so like we mentioned, the limitations of V1, which was like we were based on the polling model, and we were using cron for triggering our previous lambdas like every 10 minutes or 20 minutes. So we thought like we will maybe get rid of the polling based stuff, but not really. So we still have cron, we still have the polling based approach in our V2, where we poll for certain issues. Let's say, for example, like missing MFA or old access keys or inactive users. But some of these events are like really hard to capture on your CloudTrail API logs or the event rules. Like let's say old access keys, how do you capture on on the API calls. I mean, you have to like enumerate the user, find how when it was created, when it was used and stuff. So we have the Polar stuff, which basically runs on a cron, say nightly or whatnot. And then what it does is it will go to each account, assume a role, and do the enumeration, and then send every finding to an SQS queue, which is sent to a remediator function, same remediator function, which will again like enumerate the resource and make the decision if it should be like remediated or not. All right. So now, who needs API calls? So what we see here is we saw a big drop in number of API calls which our remediator function was making. The one spike which you see is the Polar function, which was running nightly for describing the resources. And also, if we move ahead and see how many request limit exceeded errors we got, it was almost like zero. Maybe it won't translate exactly the same for you, but what we saw was like we experienced like zero pushbacks from AWS. Okay, so what are we watching exactly? So these are the like list of things which we are watching currently. So if you look at the EC2, we have like a check for like publicly accessible AMI or an AMI shared with an unknown account or EBS snapshots publicly exposed, or same applies if it is shared with an unknown account. Missing tags, IMDS v2, and then one extra thing which we have here is a check for publicly exposed EC2 instances. And what we have done is like categorized that of like a dev account. So you have like a environment variable where you can specify what are your dev accounts, and let's say if you want like more stringent controls on that account, you can make that rule that hey, nothing, no EC2 should be exposed in dev account. And similarly, we have like multiple other remediation for IAM users, like look for inactive console access, look for inactive access keys, missing MFA. For RDS, if it is if RDS is publicly exposed, if it is if the snapshot is exposed, or if the storage is not encrypted. Similarly, it applies to Redshift, S3, and IAM role if it is exposed, or Lambda. I think yeah, the list is like pretty much like self-explanatory. All right, so moving on to the demo, which we have. Let me.
Yeah, and to jump in real quick, adding remediations to this is also pretty easy. It's not like this is just hard coded as like a monolith. It's very modular, so writing this is really as easy as writing a pretty simple Lambda that checks whatever it is that you're wanting to check. So a lot of these are sort of kind of designed around the requirements of our environment. But we've built this in such a way that you can add things to your environment. So if for whatever reason you want all of your assets to be publicly available in your DMZ account or something, like you can enforce that kind of thing too. It's really not too complicated to write one of these modules, and it's basically plug and play.
Yeah, exactly. Yeah. So like just mentioned, so our main intention was like make it modular so you can add more controls. I can actually show that. Like if I go to GitHub, AWS. All right, so if you go to resources, just a small look here on the remediator and auditor. So you basically have like multiple checks for each module. So what you can really maybe add for things that you want to watch for. Let's say you want to watch for API gateways, or you want to watch for ECS and whatnot. So you can basically add a module here. All right, so jumping onto the demo, let's make some things like publicly exposed. Let's make an AMI exposed. So we have a test AMI here, and what we are going to do is modify image permissions and make it publicly exposed. Save it. Let's do the same thing for snapshots meanwhile. So I have this, modify permissions, make it public, save it, go back to the AMI, refresh. Most likely it might be done by now, maybe not, we'll see. So it was made public, now it has been converted to private. It's almost real time, like probably took like 3-4 seconds, I think. And go back to snapshots. If we look in the permissions, it's private. So we can do the same exercise for S3 also. Let's go to S3 and just choose any of the buckets. Just slap public access, list object, and I can see because something is blocking my view. All right, so ACL public, and we can do similar stuff for lambda. Wait, for IAM role also. IAM, let's go to role. I might have a test role here. What we'll do is edit trust relationship and just allow everyone with principal star to assume this role. Update the trust relationship. Yeah, sure. It says overly permissive policies. Let's go back and we'll see if S3 has been fixed. Okay, so the ACL was removed and it's back again private. Let's see IAM, what has happened to this thing. Okay, so it basically changed the trust relationship and added deny on principal star. So basically no one can assume this role. So yeah, so basically what you can do is like you can have like multiple services and it basically will respond to it almost in real time. Let's say you're making an RDS or modifying an RDS instance and making it publicly exposed. It will capture the event and try to like see if the configuration right now is bad, as in like is it publicly exposed, is it not encrypted, and make the decision. Some things which are challenging is like RDS and redshift, because when you spin up an RDS, what happens is it takes like shitload of time, like 20 minutes, 30 minutes. So when you're using like an event-driven approach, the lambdas will trigger like immediately, right? But when they try to enumerate the RDS instance, it might not be in the available state. And that what happens is like your lambdas will see and that it's not available and they'll skip it. But once your RDS is available and it is public facing and you don't, and then you can't catch it unless your polar runs like via cron. So what we have done is like we have added some like repeat invocation. Like let's check for the RDS. If it is not available, maybe repeat the same message to SQS. Send it again like after like 5 minutes. So it will keep on checking like every 5 minutes. Is it available now? Is it available now? If it is available, check it and then make the decision. Like if it is public, make it private. If it is not encrypted, stop the instance. All right, so let's jump on to the Q&A. Do we have any questions?
Yeah, a couple of questions for me. So in this case, those little modules that you showed is when it comes to detecting something as well as responding to it. The response part, is that also built into each of the modules? Is that how?
So yeah, so basically what happens like I'll show you if I go to the code. So if I go to resources, event translator, main.py. So what happens like for each of these API calls, which are saying like create queue, set SQS queue attributes. So you have like for DP we have like some delays like 120 seconds. Similarly for these, like they are almost real time, right? Whenever this event is seen, it will forward the event almost real time to the SQS queue, and then it will trigger the remediator function. But some of the other calls we have like we have added some delays. Does that answer the question?
Yeah.
Yes. Yes. And then kind of the beauty of some of this is that because it's all relatively short Python code, if you wanted to integrate this with like, I don't know, if you have like some kind of compliance tool that has detection or remediation built in and has like an API, you can pretty easily leverage those like REST APIs or whatever to do the detection and the remediation for you. And this just kind of ties all the automation together because most of those tools that we've experimented with don't really have that. So that's something we're kind of working on building out as well, is leveraging some of the other like detection and response tools so that this kind of just glues it all together and makes it event driven. So you have lots of flexibility to do stuff like that. And the remediator modules are relatively short. It's basically just examining the event and then doing, making API calls to do what it is you want to do. So yeah, the remediations are built in and very easily customizable.
Yeah, that basically almost answered my second question, which was, the polar function, which detects something, that the CloudWatch events doesn't cover. That could easily be substituted, or something could be added onto it, which is an open source tool that does those checks or any additional stuff that you want to do.
Definitely. I mean, if you look at the Polar Core right now, what's doing it, it's watching for the similar stuff, but doing like a sanity check like every night. Let's say it's doing the same RDS check, describe RDS, describe snapshot, describe AMI, and also including the other checks like IAM user. if they are not using their access keys and stuff. So we have clubbed everything, but let's say if you don't want to use some of the stuff, you can basically remove it. So it will like do sanity check like once a night, but you can modify the cron schedule. Let's say you want to do your like once an hour or once every 4 hours, you can do that. It's very customizable. And also the whole deployment is all like Terraform and bash scripts. So it's very easy to deploy and easy to destroy.
Got it. We have a couple of questions here from the chat. From John, in the what are we watching slide under EC2, why are you watching IMDS v2 to ensure v1 is not used?
Yeah, that's exactly it. So we have a large environment with lots of apps, and because it's medical apps, there's lots of like legacy components, and there's lots of complexity. So the IMDS v2 stuff is mostly monitoring what is still using IMDS v1, and then Sahir, correct me if I'm wrong, it also flags when things are using IMDS v2 to like say it's compliant, but it doesn't it's not automatically killing things.
Yeah.
I don't believe it's written.
I mean, if you're in a state like where you can like you are like, okay, I'm in that state like where my EC2 are supposed to be on IMDS v2, you can just toggle the plug and stop and add the check for stop instances if they are not like on v1 or on v2.
And then second question from Scott, is the AWS remediation framework intended to complement or supplement the use of AWS config with its own remediation processes?
So what we have like thought of was to add config also as one of the event sources. Like right now we have polling and we have event driven. So we thought of like moving to config and like enumerate it, but we haven't like done the full enumeration part, like how config can like help us in achieving the similar state which we are achieving by event driven plus polling. I'm sure like config has the custom rules and whatnot which you can like add and do the remediation based on the custom lambdas. But yeah, something which for to do we want to like do, maybe add like a config integration where if you want, you have 3 options of like leveraging the same framework, because even with custom audit tool, you will have to have like your lambdas to make the remediation.
And
so,
go ahead.
Oh no, go ahead.
I just wanted to ask, kind of going off of that, any other sneak peek or future stuff you have in the plan for this tool?
Yeah, so I mean, Sahir and I have both kind of have mentioned it. One of the things that we're wanting to look at is more integration into other tools, as well as things like AWS config to kind of leverage this stuff. We are a relatively small team. I think we have 3 people basically kind of managing our pretty large cloud environment. So when it comes to leveraging existing tooling, our general philosophy is kind of use it all and automate the triage to clean stuff up. So really what we're trying to get into is, can we leverage existing checks and remediations from things like config, Security Monkey is dead, but like tools that are similar to Security Monkey and things like that, and leverage those checks and remediations instead of writing our own, using kind of like the REST APIs and all the fun, nice features that people are putting out there. So if we see a tool that makes this kind of stuff easy, the future state that we see for the remediation framework is kind of gobbling it up and consuming it to make this stuff more effective, giving us greater confidence that the detective capabilities are actually correct to like lower false positive rate, or just to make development quicker.
Got it. And another question for me, you mentioned that your team over there is quite small. I know that in order to get to a place where you guys are at with this tool to remediate right away, or even with a certain delay, get those remediations going in the cloud environment, you need to have sort of a in-level kind of in-depth knowledge of your cloud environment, as well as buy-in from other teams. Any kind of insights as to how you got there, fun stories or anything like that?
I think me and Sahir can both give some insight into this. So Sahir has been at Flatiron much longer than me, and he is a very beloved resource among the entire company, where I am kind of known more as the jackass who comes in and tells everybody no all the time. But I like doing that. So one of the things that we found that really made these things very successful was communicating to our engineers, because they're engineers, they like to see cool shit, and like showing them that this is cool. It means that they can experiment more as they're developing and building without worry.
Oh, we lost Justin.
Oh, am I back now?
Justin, if you could try again for the past 5 seconds.
Yeah, so that developers could experiment a little more without fear of exposing, all of our patients' data. They actually really enjoyed that idea. And then we also found that when we showed them that we had the capabilities to do these things, they suddenly had all kinds of ideas as to how they could make use of it as part of their deployment, development, and testing processes. So being able to tear down test instances after 15 minutes after their tests completed, and things like that. So a lot of the way that we got buy-in from this stuff was showing them how not only did it make the company and our patients safer, it made their day easier and gave them the ability with a lot, without having to build a whole new solution. They could like automate their testing processes and have it all be event driven, which was stuff that they wanted. So just being willing to be transparent and communicate very closely with them, and be helpful and show them how this could be like a boon to their processes, was really, really integral in getting people excited and on board with this, where we could just start flipping switches and turning remediations on, because suddenly they didn't have to worry about being the person who exposed an S3 bucket full of 20 million patients or whatever. So Sahir probably has another view on this. So
No, I think Justin, you covered pretty much everything. Yeah, so like, it's more on like how we can give more flexibility to developers. Are we confident in like making a segregated account where we can like let them do whatever they want and still have some sort of guardrails to watch for, some sort of guardrails to like detect things along with your SCPs and other preventative controls. Like, what if still things happen? Like, can we have like a framework which watches for, let's say, S3 bucket or AMIs and whatnot and fixes it automatically? So yeah, so ensuring that level of maturity is that what we're aiming for, and I'm pretty sure like software engineering kind of is like on board on that.
And then any kind of quick insight into what the cost savings were like from V1 to V2?
Oh, so we haven't like compared like specifically the cost saving. We did like actually save a lot of from the API calls perspective. Like if you look back at the slides which we had from the V1, we were making tons of API call. Like for the most API call spent was on snapshots, describing snapshot. We got to describe the snapshot, and then you have to describe for each snapshot attribute. So it was like a very, very iterative. So we had like so many API calls which were impacting other stuff with like the host creation via Ansible and stuff, because we were almost like getting pushback on the EC2 resources, always hitting the limits. So V2 basically gave us some room, like that we don't have to like describe a poll all the time. We can do it when certain events which we care about happens. So that was some of the more like API saving, the API number of API call savings, but not specifically cost. We haven't like compared yet.
yeah, the cost savings for me was our SREs quit calling, saying that API, we were making too many API calls and people were getting rate limited, which is worth like $1 zillion. Because like if I haven't made this clear, the one thing that I don't want to be doing is being on call, and getting calls at night pisses me off to no end, especially when it's an angry SRE, because the SREs do not give a shit what I have to say. They are mad that things aren't working. So that stopped, and that is worth it's invaluable. That's really all I care about, is they quit calling.
I think we can all agree there. A couple more questions from the chat. Have you tested or compared this with AWS Guard Duty?
So we do use like guard duty, but then guard duty, like, it doesn't capture everything what we want. Let's say sure, it might have like for S3 checks and everything, but for like specific stuff like which we're looking for, like IAM roles and whatnot, I'm not sure if it is being covered in guard duty, but we do complement that with like using guard duty like standalone.
Yeah, to kind of to add to that, like we said before, I don't necessarily believe in replacing free things. If there's things that do things well, we will use them both as best we can, and then try and write some code to glue it together. So we have a lot of, when you ask these questions about these things, very often the answer is we're using both of them as well as this.
Got it. And another one, for some cases, why not create a preventative SCP?
Sure, yeah. This one, go ahead.
Yeah, absolutely do that. You should do that. This is another layer helping us, validate that the SCP hasn't changed, or that I didn't fat finger the SCP, or honestly, I'm not that smart. I might have written a bad SCP, and I like having the many eyes approach and like the defense in depth approach of, maybe I wrote a bad SCP and this is something we can use to detect. Damn it. We can use to detect, something going public again. So we have both. We're using SCPs. You should be using SCPs. They're a great preventative control. I also would say that having preventative controls does not mean you should avoid having detective and responsive controls as well. You need multiple layers.